In this video, we'll take a look at some of the related calibration information in Excel. So I have a calibration set of data here. I've plotted it on a graph, and probably you already know that you can add trend lines in Excel. So I'm going to go ahead and click on the plus sign next to my chart, go to trend line, but choose more options. This will allow me to set up all of the details. We're almost always using linear trend lines in Excel. If you're doing something with, for example, a thermistor, you might need to go polynomial or logarithmic, but we're not usually doing that in this context. So that's future work. I set my linear trend line. I might want to set it to have a 0 intercept. I may choose not to. I definitely want to display the equation, and I also want to display my r² value, usually. So once I've set those up, let me just increase the text size so we can see this. So now we have a calibration curve. I'm going to show you the error bars in Excel. I can add those on the same chart element. And again, here I usually do more options so that I can set it up the way I really want it to. With the measurements that we're doing, we're never going to have horizontal error bars. We're looking for just vertical because, oops, and that deleted both columns. Hold on, let's try again. Oh, I see. So it's actually just so small you can't quite see it here. So you can set your error bars to be a percentage. Let's imagine we have a pressure sensor that's quoted with 5% accuracy. If it's a 5% relative to the measured value, that would actually be a proper error bar. If, on the other hand, it was 5% of the full scale value, that would be a fixed value. On this one, it would be 5% of 30 psi, which would be quite small. So my calibration data here wouldn't be very good for that sensor. If instead I knew it was, plus or minus a half psi, I can put that information in. I can also do a standard error. And this is the one in Excel that I never use because they don't provide any theory on where they're calculating their error. So the final way you can do this is using our hand calculation from class. You can calculate based on your calibration curve what that fixed value should be. And I'll post the final values for this particular calibration curve. But let's say I found a 90% confidence value was plus or minus 2.5. I would put that fixed value in here. And now those error bars are determined using proper statistics for this analysis. So I avoid using standard error. I'm not sure standard deviation applies to our applications. Percentage often does, or fixed value does, and you might choose it based on a sensor specification sheet or based on our statistical analysis and the standard error of the fit.